Hello everyone, welcome to my YouTube channel Easy Way to Learn. I'm Shalja Tripathi and in today's lecture we'll be doing questions based on significant figures. So let's get started, remain focused and follow the series. Let's see our first question. See, given the numbers 786, 0.786 and 0.0786, the number of significant figures for the following numbers is, see, for 786, there are three significant figures. As the rule says, all non-zero digits are significant. Again, 0.786, it has three significant figures. Again, all non-zero digits are significant. Then 0.0786. Here again we have three significant figures because 0 to the right of the decimal and before a non-zero digit is not significant. Hence this number, this 0 is non-significant. This 0 is non-significant. So all the three numbers have three significant figures. So option B is correct. Now let's see another question. See, it says the number of significant figures are. See, for question number 2, we have a number 0.0500. Again, the rule says 0 to the right of the decimal and before a non-zero digit is not significant. So this 0 is not significant. It is just used to denote the place of decimal. And rest of the digits are significant. So it has three significant figures. So option B is correct. Okay. The number of significant figures in pi are. So we know pi is an irrational number. It is an irrational number. Hence, it has infinite number of significant figures. 1 torr is equal to 1 millimeter of mercury. Torr is the unit of pressure and millimeter. Let's see this question. The correctly reported answer of addition of the following numbers will have how many significant figures? So we have three numbers. See, 29.4406, 3.2 and 2.25. See, we have to do addition. And in addition, rule says that we have to report the answer based on the number which has least number of decimal places. So 3.2, so 0.2, it has only one decimal place. So here we have least number of decimal places. Decimal place. See, this has 4 decimal places, 2.25 has 2 decimal places. So we have to report the answer up to 1 decimal place. So on addition we get 9, 8, 14 and here we get 3. So our answer should be reported as 34.9. We round off the number. So this number is greater than 5. So we add 1 to the preceding number. So this will be our answer. So number of significant figures that it has is 3. So this 34.9 has 3 significant figures. So option A is correct. Now we have number 108 divided by 10 point, 108 divided by 7.4. So answer is 14.594. So the correct answer to the problem in proper number of significant digits is. So rule for multiplication and division says that least number of significant figure in the question will decide the number of significant figure in the answer. So 108, it has 3 significant figures. This has 2 significant figures. So among the two, this is least. So our answer should be reported in 2 significant figures. So after rounding off, we get 15 as the answer. So this has 2 significant figure. So option A is correct. Now let's come to another next question. 1 Fermi is the unit of length for measuring nuclear diameter. It is equal to, see, 1 Fermi is equal to 1 femto, and this is equal to 10 raised to the power minus 15 meters. See, Fermi is based, this unit is based on the name of scientist Enrico Fermi, and femto, it is a prefix, and both are equal to 10 raised to the power minus 15 meters. See. So option C is correct, that is 10 raised to the power minus 15. Now next question says two students X and Y reported the mass of same substance as, see, X and Y are reporting mass of substance as 7.0 gram and 7.00 grams respectively. Which of the following is correct? Both are equally accurate. X is more accurate than Y, or Y is more accurate than X. Both are inaccurate scientifically. See, we'll first see number of significant figures. Here we have 2 significant figures and here we have 3 significant figures. So this is more accurate as compared to X. So Y is more accurate as compared to X. So option C is correct. Okay. Next question, light travels with the speed is given. Distance traveled by light in 1 femtosecond is. Okay. See, speed is given 3 into 10 raised to the power 8 meter per second. Time is given as 1 femto. And we know 1 femto is equal to 10 raised per minus 15 seconds. 1 femtosecond is equal to 10 raised per minus 15 seconds. So using the formula, distance is equal to speed into time. We'll find out time. So let's see what we get. 3 into 10 raised power 8 into 10 raised power minus 15. So here we get minus 7. Meters. But we have to report the answer in millimeter. Options are in millimeter. So to convert this into millimeter, use unit factor. See, 1 meter is equal to 100 centimeter, and we know 10 millimeter is equal to 1 centimeter. So using this, we can convert this meter into centimeter. Okay. So 1 meter will have, see, 1 centimeter is 10 millimeter. So we can multiply here. So we get 1000 millimeter. So 1 meter is equivalent to 1000 millimeter. So 3 into 10 raised power minus 7 multiplied by 10 raised to the power 3. So you will get 3 into 10 raised to power minus 4 millimeters. That is equal to 0.0003 millimeters. So our option D is correct. Now let's see this question. In which of the following numbers all the zeros are significant? Okay. So in case of option A, see 0.00, again one more 0, 5. So all the three zeros are non-significant because the rule says zeros are on the right of the decimal and before a non-zero number are not significant. So these are not significant. Okay. And option B, 0.0500, again this 0 is not significant. Option C, 50.000. See, all the zeros are significant. So here all the zeros are significant figures. Again in option D, 0.0050. So zeros preceding this 5 are not significant. So in which of the following number all zeros are significant? So option C is correct. This question, see which of the following is correct. So here option B is correct. 1 liter is equal to 1 decimeter cube. Now let's see how we'll derive this. See, you must remember 1 centimeter cube is equal to 1 milliliter. Multiply by 100,000 on both the side. So what you get, 1000 centimeter cube is equal to 1000 ml and 1000 ml is equal to 1 liter. Now we can convert this centimeter cube to meter cube by dividing by 100. See, so this is nothing but 10 into 10 into 10 centimeter cube. That is, centimeter is coming 3 times. So what you will do, divide by 100 into 100 into 100. So what you get, 10 raised to the power minus 3 meter cube is equal to 1 liter. Now we can convert this meter cube into liter. Use this information. 10 decimeter is equal to 1 meter, or what we can write, 1 decimeter is equal to 1 upon 10 meter. Using this information, what we can write, see, 10 raised to the power minus 3 meter cube means 1 upon 10 into 1 upon 10 into 1 upon 10 meter cube. And 1 upon 10 meter is 1 decimeter. So this is equivalent to 1 decimeter into 1 decimeter into 1 decimeter. That is, 1 decimeter cube is equal to 1 liter. So here we get the relation. So option B is correct. Now let's see this question. Which of the following properties of an element is not variable? See, our correct option is atomic mass. Valency, equivalent mass and oxidation states, these are variable characteristics or variable properties. So atomic mass of an element is the fixed characteristic of it. Now let's come to this question. If density is 3 point, see density is given as 3.12 gram per ml. And mass of the solution we have to find, and volume is given as 1.5 ml. So mass of the solution in significant figures we have to find. So we know density is equal to mass by volume, or density into volume will be equal to mass. So density is given in 3 significant figures and volume in 2 significant figures. So we'll take the least significant, will decide the answer. See, this is 1.2 into 1.5. On multiplying, see here we have 3 significant figures, 2 significant figures. So answer should be reported in 2 significant figures. So here if answer is to be reported in 2 significant figure, we will do the rounding, add 1 to the preceding number since 8 is more than 5. So we get 4.7 grams. So this is reported in 2 significant figures. So our option A is correct. Number into scientific notation, what we have to do, we have to express the number in this form, where capital N is value between 1 and 9.99. So in this case, we can write it as 48 upon 1, 2, 3, 4. Now what we can do, we can write 4.8 into 1 upon 1000. We have used 1 zero to place decimal. So this is 4.8 into 10 raised to the power minus 3. See, this n can be both positive or negative value, positive or negative. So exponent can be positive or negative. Or simple way of doing is, if you have to shift the decimal to the right, if you are shifting the decimal to the right, the power will decrease. And if you are shifting the decimal to the left, power will increase. Remember this trick and you can solve it easily. See, we come to this question, next question. See, 234 into 10 raised to the power 3. Now we have to shift the decimal to the left, or we have to place after 2 digit, 1, 2. So we are moving it to the left. That means we have to increase the power. So mathematically how we do, divide it by 100 and multiply by 100. So this is used to place, this 100 is used to place the decimal. We get 2.34 into 10 raised to the power 5. See, in this question 8008. Again you have to place the decimal here. That is, we are moving towards left. So if we are placing decimal 3 after 3 places, will increase the exponent by 3. So we get 8.00 into 10 raised to the power 3. Similarly, in this case, again we have to shift this decimal 2 places to the left. So what we get? 5.00 into 10 raised to the power 2. So in this case, it is already in scientific notation form, so we will not change this. It will remain as such. How many significant figures are present in the following? See, in this case, there are two significant figures. Here, these two zeros are not significant. That is, zeros after or zeros to the right of the decimal and before a non-zero digit. So here we have two significant figures. Here 208, that is 0 between two non-zero number is significant. So total number of significant figure is 3. Again here two zeros between two non-zero number will be significant. So it has 4 significant figures. Okay. Here terminal zeros will not be considered significant because there is no decimal place. See, if it would have been like this and a decimal place, then these terminal zeros would be considered as significant. Since there are no decimal, there is no decimal placed here. Hence, we have 3 significant figures. Terminal zeros are not significant. See, in this case, since there is a decimal, so these zeros will be considered significant. So here we have 4 significant figures and here 1, 2, 3, 4, 5. 5 significant figures. Round up the following up to 3 significant figures. See, in this case, sir, we'll round it up to 34.2. So it has 3 significant figures. Okay. In this case, it will be 10.4 here. See, this 0 after the decimal and before non-zero digit number is not significant. So this will not be considered. So this 0 is not significant. So what we write 4, 5, 9. And since after 9 we have number which is greater than 5, so we'll add 1 to the preceding number. See, now it will become 0.0460. So we have 3 significant figures here. So 460 is considered, these 3 are considered significant. Again, here we add 1 to the number, so what we get? 2810. So we have to give the answer in 3 significant figures. So these 3 numbers are significant and terminal 0 will not be considered significant because there is no decimal after 8. So if there is no decimal, so this won't be considered as significant. If it is written as 2810, then if a decimal is placed, this 0 will be considered as significant. But since there is no decimal, so this terminal 0 will not be considered significant. So again, it has 3 decimal places. Significant figure should be present in the answer of the following calculations. See, in multiplication and division, we will first find the number which has least number of significant figures, and that will decide the number of significant figures in the answer. So here we see 0.112. This has 3 significant figure, which is least. Rest are having more. See here, 2, 8, 5, 6. It has 4 significant figures. See, 0.02856. It has 4 significant figures. Again, 298.15. It has 5 significant figures. Here 0.5785, it has 4 significant figures. So least among them is 0.112, which has 3 significant figures. So answer will also have 3 significant figures. So it is just asking how many significant should the answer have. So here it should have 3 significant figures. Okay. Let's come to the next question. See, our question is 5 into 5.364. See, this is a pure number with no decimal. So 5 can be 5 balls or any object. So here significant figures, number of significant figure is infinite. In this case, number of significant figure is 4. So least among them is this. So answer should also have 4 significant figures. So in multiplication and division, we decide the number of significant based on the number which is having least significant figure in our question. Okay. See, in addition and subtraction, decimal will help us to decide number of significant figures. See, 0.0125, 0.7864 and 0.0215. See, all the values are having 4 places after the decimal, so our answer will also have 4 places, should have 4 places after the decimal. See, so we have to report the answer in 4 places after the decimal. So this is our exact answer and it has 4 significant figures. See, 1, 2, 3, 4. 0 between non-zero numbers are significant. So here 4 significant figure. Again in this case we had 4 significant figure. So these are the correct answers. This question, 2 students performed the same experiment separately and each one of them recorded 2 readings of mass which are given below. Now we have to find the correct answer and the correct reading of the mass is 3.0 grams. So what we'll do, take the average of these 2 readings so that we can compare it with the true reading. So average of these 2 will come out to be 3.00 and this will also come out to be 3.00. Now let's see the first reading. See, both the readings are very close. So hence the readings are precise and the average value is equal to the correct value or true value. Hence, the result reported by A is both precise and accurate. So this is the correct option. Now let's see B. Here the values are not precise because there is difference in the first and the readings are far apart. In this case, readings are far apart. Hence, the readings are not precise, but the reading is accurate because it is same as the true value. So result of student B is neither precise nor accurate. This statement is incorrect. Result of B is both precise and inaccurate. This is also wrong. Result of both the students are neither accurate nor precise. This is also not correct. So here we have, in case of student A, readings are both precise and accurate. In case of B, reading is not precise but it is accurate. So it is not precise but it is accurate. Temperature on Fahrenheit scale is given 200 degree Fahrenheit and we have to convert into Celsius. So for conversion we must know this relationship. Fahrenheit, degree Fahrenheit is equal to 9/5 degree Celsius plus 32. Now using this relationship we can easily find degree centigrade. So let's write down the values. 200 is equal to 9/5 degree T degree Celsius plus 32. So 200 minus 32 is equal to 9/5 T degree Celsius, or we can write 168 into 5/9. This comes out to be 93.3 degree Celsius. So this is our correct answer. Option third is correct. How many significant figures should be present in the following calculation? Again, in multiplication and division, we'll check the number which has least significant figure and that will decide the answer. So here the least significant figure is 2. See, 2.5 has two significant figures. Again, 3.5 also has two significant figures, and rest, that is 1.25 and 2.01, they have three significant figures. So the answer should have two significant figures. So least number of significant figures in the question will decide the number of significant figures in the answer. Okay, let's come to another question. Okay, this is assertion reason question. Significant figure for this number is 3. 0.200 is 3. It is correct. That is, zeros to the right of the decimal and also to the right of a non-zero digit number are significant. Whereas for 200, it is one significant figure. It is also correct because terminal zeros are not considered significant if there is no decimal. So statement, that is assertion, is correct or assertion is true. So this is true. Now let's see the reason. See, zeros at the end or right of a number are significant. That is, the zeros at the end or right of a number are significant provided they are not on the right side of the decimal. So this statement is false, because what we are saying, that zeros to the zeros at the end or right of a number are provided if they are on the right side of the decimal. So this statement is false. So assertion is true, but reason is false. Hope you understood these questions well. Please like, share and subscribe. Keep practicing. Thank you so much.